In this lesson, we're going to talk about classifying triangles. There are two ways that we can classify triangles. We can classify them by the measure of their angles, or we can classify them by the length of their sides. The first part here is where we're going to learn about classifying triangles by angles. All right, the first one that we have is an acute triangle. An acute triangle has three acute sides. Now remember that when we're talking about acute sides, those are sides that have a measure of less than 90 degrees. All right. So um, if you have a triangle that all the angles, all the inside angles here are less than 90 degrees, that would be classified as an acute triangle. All right. The next one is an equiangular. Equiangular means that all the angles are the same measure. All right. So an equiangular triangle has um, an angle, all three angles that measure 60 degrees. An obtuse angle has one obtuse angle. Remember, an obtuse angle is larger than than 90 degrees. And so you would have two acute angles, like here and here, and then one that's larger than 90 degrees. And one of the things that you can always do is, if you're not sure if it's larger than 90 degrees or not, just take a piece of paper and hold it up to the angle, because the corner of a piece of paper, of course, is 90 degrees. So you can tell if you line up one side of the paper to the side of a triangle, if it if it if you can see the other side, then you know that it's more than 90 degrees. All right, and the last triangle that we're classifying by their angle measures is a right triangle. Okay, which means it has one right angle, and remember, a right angle is designated by the little square here that we have. And of course you remember that a right angle is equal to 90 degrees. Okay, so let's go ahead and pause the video and copy this table and the little notes that you need into your notebook, and then we're going to go ahead and do some practice problems. Okay, the first practice problem that we're going to look at is one that has a an angle of 50 degrees, an angle of 40 degrees, and an angle of 90 degrees. This is the important one right here, because we know that a 90 degrees is a right angle. So if it has one right angle, this would be a right triangle. The next triangle that we're going to look at is, we're going to look at the angles. We have two angles that are 50 degrees and one angle that's 80 degrees. So we know that all the angles are are acute. And so this would be an acute triangle. In this triangle, when we look at the angles, we have an angle that's 30 degrees, angle that's 50 degrees, and an angle that's 100 degrees. A 100-degree angle is obtuse, because it is more than 90 degrees. So this means that this is an obtuse triangle. And the last one that we're going to look at, we see that all the angles measure 60 degrees, all three of them, and so this is an equiangular triangle. Okay, so the next classification system that we're going to look at is classifying triangles by the length of their sides. All right, once again, if you have, just as a reminder, if you have these little hash marks here, those are your congruency hash marks. So you can see in this triangle here, all three sides are congruent, which means that they have the same length. So this, if they have the same length, then it's an equilateral triangle. All right. In the second one, an isosceles triangle. An isosceles triangle has two congruent sides. And then this other side here is not the same length. So that means you'd have two sides that have the same length and one side that's a different length. That's an isosceles triangle. And then a scalene triangle is one that all the sides are different lengths. There are no congruency symbols or congruency hash marks there, and all three of the sides are different lengths. So that is a scalene triangle. All right, so let's go ahead and pause this video and copy this table into your notes. All right, so if we look at this triangle, we have if we look at the sides, this side from here to here is 5 centimeters. From here to here is 12 centimeters. And from here to here is 13 centimeters. So we know that all three of those sides are different lengths, which makes it a scalene triangle. The next one, we don't have any actual measures, but we have the congruency marks. So here we have one set of congruency marks showing that two sides are congruent. And if two sides are congruent, that means that is an isosceles triangle. All right. In this case, we're not given any measurements or any hash marks at all. We're just given expressions that determine the lengths of the sides. So it says to find x and the length of each side if triangle ABC is an isosceles triangle. Okay, isosceles means that two sides are congruent. Or equal to each other, and that AB is congruent to BC. So AB, 4x minus 3, is congruent to 2x plus 5. So it says to find x and the length of each side. Well, so what we're going to do is we're going to say 4x minus 3 is equal to 2x plus 5. Let's solve for x. So they'll go minus 2x minus 2x. The x's cancel out on the right-hand side. If we simplify, 4x minus 2x is 2x. Bring down the minus 3 is equal to 5. Add 3 to both sides. We end up with 2x, once these 3's cancel out, 2x is equal to 8 divided by 2. X is equal to 4. All right, so x is equal to 4. And then to find the measure of the sides, we just substitute the 4 in for x. So this would be 4 times 4 minus 3. 4 times 4 is 16 minus 3, which is 13. Okay, so the length of this side is 13. And because the side AB and BC are congruent. We should know that this over here is also 13, but let's just plug it in just to check. 2 times 4 plus 5. 2 times 4 is 8, plus 5 is indeed 13, which leaves us with the bottom here, AC, plug it in. 4 plus 2 is 6, and so the length of AC is 6. One last problem, and it says to do the same thing, find x and the length of each side if triangle FGH is an equilateral triangle. So equilateral, remember, means all sides are the same, or all sides are congruent. Okay, so we can pick two of these and set them equal to each other, and it doesn't matter which ones we're going to pick. I'm going to pick this one and this one. All right, so let's say 5x minus 8 is equal to 4x plus 1. I'm going to solve for x, subtract 4x, subtract 4x. I always subtract the smallest value, smallest term from the larger term. So 5x minus 4x is 1x minus 8 is equal to 1. Let's say plus 8 plus 8. The 8's cancel out. 1x is just simply x is equal to 9. So our value of x is 9. So once again, we plug them in. So we got 5 times 9 minus 8. 5 times 9 is 45. 45 minus 8 is 37. All right. Let's just, so all sides should be equal to 37. But let's just plug it in. On the bottom one, FH, we have 4 times 9 plus 1. 4 times 9 is 36 plus 1 is 37, which is correct. And on the one side that we haven't worked with at all, 3 times 9 plus 10. 3 times 9 is 27, plus 10 is 37. So indeed, all three sides are the same length. It's always a good idea to plug your values in just to check to make sure that you didn't make a careless error someplace. Okay, so that does it for this lesson. Go ahead and look at your classwork and make sure that you ask me any questions if you have anything that you don't understand. See you later.